Okay, everybody, let's multiply a monomial to a polynomial expression. So if you look here, here's your monomial, negative 7a. Here is your polynomial because you have many terms, 1, 2, 3. That's technically called a trinomial. We know when we have something on the outside of a parentheses, a monomial, that means to distribute, to multiply this term to all the other terms. There is no paper trail. It's all done here. My helpful suggestion to you would be to make the rainbows like I do. Make the connection so you can see what you're multiplying. So a negative times a negative is a positive. 7 times 8 is 56. A times a cubed. Well, to multiply variables, you need to add the exponents. What's the exponent understood to be here? 1. So 1 and 3 would make 4. So that would be a to the 4th. A monomial times a monomial is a monomial. Now we'll go again. Next rainbow. Negative 7a to the 1st times positive 9a squared. A negative times a positive is a negative. 7 times 9 is 63. A to the 1st times a squared. We would add the exponents, we would get a cubed. Okay, but we're not done. We got to make another rainbow. We have another term to distribute. Negative 7a to the 1st times negative 1. A negative times a negative is a positive. 7a to the 1st times 1. Well, we know in arithmetic 1 is your identity element, which means anything you multiply to 1 stays the same. So 7a to the 1st times 1 would be 7a to the 1st, but we don't need to write the exponent 1, it's understood. Now let's look, are we done? We have 3 terms. There's no more parentheses, which means I'm either subtracting or adding. Can I add and subtract these terms? Well, if you go back to add and subtract, things have got to be alike. Is an a to the 4th, an a cubed, and an a alike? No. To add and subtract, the letters have to be identical. An a to the 4th may be apples, an a cubed may be applesauce, and a may be apricots. So we can't go any further. We are in the correct descending order because our exponents go from 4 to 3 down to 1. So this would be our final expression. Okay, let's look at the next one. We are multiplying 9xy squared. That's a monomial. It's all connected by multiplication. We are multiplying to 1, 2, 3 terms. Well, the only way to do that is use the distributive property. There's no paperwork. It's all up here. So, ladies and gentlemen, you have to go slow and not make careless mistakes. Again, my helpful hint is make the rainbow. All right, so first I'm going to multiply. 9 times 4 is 36. X can multiply to x. We got to add their exponents. There's an invisible exponent of the 1. There's an invisible exponent of the 1. 1 and 1 would make x squared. You might as well memorize right now. Till the day you die, algebra doesn't change. X times x is always going to be x squared. Always. Just memorize it. X times x is x squared. Now, there's a y squared. There is no y in this term. So we just bring that down. Okay, because it has nothing to multiply with. That's a monomial. It's all connected by multiplication. Are we done? Nope. Let's make our next rainbow. Positive 9 times negative 6. A positive times a negative is a negative. 9 times 6 is 54. We have x times x. Again, that exponent's 1, this exponent's 1. Till the day you die, x times x is x squared. Now we have y squared, and we can multiply it by y. There's also an exponent of 1. Y squared times y to the 1st is y cubed. Everybody's good? Awesome. Are we done? Nope. We still have another term. We're going to multiply and make another rainbow. 9 times positive 11 would be positive 99. We have an x. Well, there is no x here. We don't forget about the x, you just bring it down. You just write x. We have y squared times y squared, and that would make y to the fourth. So all we learned right now is you could do the distributive property with any type of monomial, whether it be a number or it be a variable or a product. Now, the question is, are we done here or can we keep going? Well, we have three terms. We see adding and subtracting, so they would have to be alike. Is an x squared y squared like an x squared y cubed? People, do these look alike? No. That's a y squared and that's a y cubed. They stand for totally different concepts. So no, you cannot add these guys together. Does an x y to the fourth look like any of these other terms? No. So we can't add any of these terms together. Now somebody's going to say, what about descending order? Well, the rule of thumb is when you're dealing with algebra, if you only have one variable, a, yes, descending order matters. So that's why this has to be written a to the fourth, a cubed, a. But when you have two variables, both an x and a y, then order is not important, because how do you decide? Do you put the x's in descending order or do you put the y's in descending order? So if you have more than one variable in your expression, it doesn't matter what order we write our terms in. So I would just leave our answer like that. And that is how you distribute any type of monomial.